Welcome back. We're going to take a look at file linking and modular programming today, which really mostly just has to do with how to separate our files so that we're not just working in one the entire time. Okay, so to begin, we're going to make a utility file. It's going to have a bunch of functions like cook, salt, and serve, and a class called food item. So let's get this started. Here, let's open Jupyter. And let's go into public videos, file link, and this will be exercise 1. Okay. Now, actually, what I should do is I shouldn't have just, so I'm very used to doing example 1.cvp, as you can see. What I'm actually going to do is I'm going to make some folders. So the first folder will be exercise 1. And in here, we're going to start with our utility file. And this is going to be the one that has our little functions that take our food items. So first, let's make our food items. Probably even better is actually to have a separate file for our food items. So let's do that. Food item.cpp. And we'll just make a really simple food item class. I'm not going to spend too much time on this class just because I want it to just be something we can work with. I think I need to include IOStream. Use the standard namespace. We'll just make sure it has a name. Things we're going to do include cooking, salting, and served. So let's just make some booleans for these. Cooked, bool, salted, bool, served. Yeah, I think that's fine. Oops. Let's make a constructor, food item. We'll make a blank one, and we'll also make one that accepts these things. So name, cooked, salted, served, and assign them to each of those. Cooked, salted, served. Okay, so I got a really simple food item, nothing fancy going on here, and it's all public just because I want to be able to quickly show how some of this interacts. Now that I have my food item, I need to include food item.cpp. Otherwise, my utility function has no idea what a food item is. And now that I have that, I can make my other functions, such as cook, which will take a food item, F, and let's say we do something simple, such as we'll output cooking f.name, and we will set f.cooked. Is it cooked? Yeah, cooked is true. Actually, instead of passing these parameters, I want to make things a little shorter. I'm actually not going to pass these. I'm just going to assign the name, and we'll set everything else as false to start. False, false, false. And that way we can make our functions actually set these to true. And otherwise we won't allow it. Okay, so here's cook. We'll do salt, and we'll do served as well. Salt, salting, salted, cooked, serving, served. Okay, so now I have my utility functions, I have my food item class, and now finally I want to make my main function. My main function is going to include util.cpp. And in here, I'll make my food item. Is it food item with a capital I? I keep forgetting. Capital I, yes, I did that here. Food item F equals food item, and we'll say that this is, I don't know, tacos sounds good to me. Let's see what f.cooked is, and salted and served. And then we'll call our utility functions. So those are called cook, salt, and serve. So we'll cook f salt and serve it. Also, while writing these, I'm realizing that I have passed all these as copies, which I shouldn't. I'm going to be adjusting them. I should be passing each of these by reference. And they're not constant functions because I'm modifying them all. And let's see what this prints out at the end. To compile this, it's actually very simple. Because my main function includes the utility, which then includes the food item, I only have to compile one thing, which is the main. So simple, although inefficient. So I got all zeros because they're all false. I'm cooking, salting, and serving the tacos, and now they are all complete. And that's it. So we have now a little program where this one depends on this one, which depends on this one. Something else important to note is that I only included IOStream in the standard namespace in my food item. However, I needed to use cout in my utility. But rather than writing these things a second time, I can always rely on the fact that, oh, by including my food item, I've already used the standard namespace, I'm already including IOStream, so I don't have to write it again. I can if I want, it just won't do anything. So that ends exercise 1. Let's move on. For part 2, we're going to make a dish class, and our dish class is going to have a vector of food items. We're going to separate the declaration of the dish class into a header file, and the implementation into a CPP file, and our header will be included in our main. So let's see what this looks like. First of all, I have to copy all of these 3. Let's close everything. Now, I need a new file, and this one is going to be my dish class. So class dish. My dish class needs to have a vector of food items. We call it foods, which means I also need to include food item.cpp because I need to know what a food item is. Now, what did it say we have to do here? Basically just create it. So let's make sure that we can make it work. Put the comment in here. So in order for this to work, well, this is already public, so it's pretty simple, I think. Maybe perhaps I will just give this a method that says display, which is a void function, where I simply go for food item f in foods, cout f.name, new one. Okay, so I got my dish. My dish just has a vector of foods, and I can display them all. If I want to add to them, I basically have to access foods directly and use the pushback method. I suppose if I want to be very nice, I can give it a method for that. Add food, given a food item f, foods.pushback f. And then I can actually make this private, which is what it should be. Okay. Now my main function needs to include dish.cpp. And now let's see if I can put a bunch of tacos in my dish. So dish d.add food f. Let's do that 3 times and then display. Call it display, right? Yep. Okay, let's see what happens. Now, it's not going to work, and I'll talk about why first. We're going to compile. Let's say we compile main. Actually, no, I didn't follow the instructions, did I? I was supposed to separate into a header file and a CVP file. So we wrote the whole code in our dish class, but we don't want all of this here. Actually, what we want to do is we want to have a second file, which is going to have the header. We'll call this one dish.h. So the difference between these is that my dish.cpp, instead of including all this stuff, is actually just going to include dish.h. And in here, all I need to do is write my functions. So I have the add food function from the dish class. I have the display function from the dish class. Pull this back. And this is the entirety of my CVP file. And I can delete this actually. My header file should only tell me what a dish is, include the other stuff that I need, but it shouldn't actually have the functions themselves. So rather than writing all the code, I can just say semicolon. And the nice thing about this is now if I really need to know how things work, I can go to the CPP file and see all the code. And if I just want to know what is a dish, I can see here it's a thing with a vector of foods, and it's got some functions to add food and display them. Now that I have these separated, my main function should just include dish.h. And here's where we're going to start running into some issues of things we have to fix. So number one, I compile main.cpp. It is pretty mad about redefining what a food item is. And the reason for that is that my header file here includes food.cpp, and it needs to because I have a food item there. But I also include it from including my utility file. So I'm including the food item CPP multiple times, which presents some problems. There's a few ways to solve this. The simplest way is to write this, pragma once. And by doing this, I instruct C++ never to include this file multiple times. So now this error is gone, and I get a different one. And this one's much more confusing if you're not used to it, which is it doesn't understand what dish add food, and dish.display are. It sees that these are functions that exist, but it could not find the actual code for them. And the reason is dish.cpp over here has the code. But I never told it dish.cpp existed. All it knows is there is a header file called dish.h and a utility file which has other code. So to explain that I need both, I need to actually include both main.cpp and dish.cpp. And now my code does what I want. There's my 3 tacos. Okay, so that's it for this exercise. Now we can move on. All right, part 3. We'll make a restaurant class in another set of header and CPP files. Restaurants should have an array of available dishes. We'll include food item, dish, and restaurant in our main function, our main program, and instantiate objects of each one. Okay. So once again, I'll make copies of all this. Exercise 3. Paste. And now I need a restaurant. Let's do the header file first. So in order for my restaurant to work, I need to know what a dish is. So I will include dish.h. I think it just needs an array of available dishes. Otherwise, I can kind of do whatever I like. So here, let's say that our restaurant will never have any more than 20 dishes. So class restaurant. And we'll say there is a constructor for our restaurant, which sets up a dynamic array for us, which means that we'll need to have our available dishes, which will point to an array. And let's say that we want to be able to add them. In order to do that, I need to know num of dishes and also max dishes equals 20. And now I can write a function that's void add dish and a function display dish. Just display sounds fine. And here, this is just my header file. There's no real code in here. I mean, there's one statement, but that's it. And the actual implementation of all of this is going to go into my restaurant.cpp. Restaurant.cpp here is going to include restaurant.h. And now I just need to implement these functions. So I don't need these things. I don't need to know the name of the class. I just need to have my restaurant constructor and the 2 functions that go in it. In my constructor, I will dynamically allocate the memory I need. So this is going to be a newly dynamically allocated array of dishes, of which there are max dishes number of them, so I don't need this anymore. I suppose the number of dishes should initialize as 0 to start, and as I add them, I will put them into new places. Num of dishes. So to add a dish, I will say num of dishes plus plus. First of all, if num of dishes is greater than or equal to 20, then I have too many. And I will say no room for more dishes. Otherwise, available dishes num of dishes is, I guess to add dish I need a dish, huh? Dish D. Dish D. I suppose you can pass by reference. That's probably fine. Maybe I'll put in a copy, though. Maybe I won't pass by reference here. This is a design decision. There may be multiple reasons to do one or the other. But we'll say that dish is D, the one that we're adding. And number of dishes has now gone up by 1. And now to display, for I is 0, I is less than the number of dishes, I plus plus will output. So each dish has a collection of food items. So actually what we'll do is that for each dish, we will display the dish. So available dishes, I.display. So if I did this correctly, my restaurant should create a new dynamic array of a space for 20 dishes. I can add dishes to my restaurant. I can display all the dishes that are there. And now let's see if I can make some stuff. So in my main function, I need to include restaurant.h. And so right now I have this first dish, which is just 3 tacos. For the sake of distinguishing things, I probably should give this a name. Let's say string name. Let's see. I don't even have a constructor for this. It's a really simple dish class. I suppose we'll make sure each dish has its own name. And we'll assign that as part of its constructor. Dish nothing, or I can do dish d string n, assign it to the name. Yeah, that seems fine to me. This code is so short, there's no point putting it in the CPP file. It's just a very simple constructor. But here I'll leave these ones. They're a little longer. So now when I make a dish, I can either make it empty like so, or I can give it a name. So we'll call this 3 tacos. And now let's play around with the stuff that we have. So I can make a dish that's 3 tacos. Let's say I make some more food items. So let's say I want to, spaghetti will be F2. F3 will be bolognese. And then dish D2 is dish spaghetti bolognese. And now let's make our restaurant R. Does my restaurant have a name? No, but that's okay for now. I guess if we need to make more restaurants, we can do that. Restaurant R, and then R dot, what's our function? Add dish. D. And then add D2. And then finally, display. And let's cut out all the other display stuff. Don't need to show that, don't need to show this. Just want to see this working. But we're gonna have some problems first. Let's see what they look like. Okay, to compile, we saw that we need to compile main and dish. No such file as restaurant.h. Did I spell it correctly? Restaurant.h. Looks correct to me. Oh, am I in the right folder? The answer is no. Ooh, I made all these changes to the wrong one. This is the thing you'd be careful about when you're working in multiple folders. Is I think what I did is I changed everything in the wrong place. Yeah, okay. So I think we can fix this easily enough. What we're gonna do is so I think our main here, this was our old main. This was our old food item. We didn't change that at all. I think our dishes didn't change either. So I think the only thing we changed was we added restaurants. So we'll cut this. I'll put this in this folder. And I'll rename these folders. Let's just swap this around. So make this 4. This will be 2. And this will be 3. And now I've put everything in the right spots. So now my dish has its name. My food item hasn't changed. My main function has all the stuff we just did. And my restaurants are in place. Okay, so gotta be more careful in the future. It's a lesson for myself. Main. So I compile main. We see redefinition of class dish. So here again we have dish being included multiple times. So I need to fix this. So in my dish header here, we can either write pragma once, or another option that you can say is if not defined dish.h to define dish.h, and at the very end if. And this has the exact same effect as pragma once. It's just an older way of writing it, which works on older versions of C++, where pragma once does not. But it does effectively the same thing. If we haven't seen dish.h before, define it so that we know that it exists and we don't go here more than once. Oh, sorry, you shouldn't use a dot in this, so it should be _h. It's a bad practice. Okay, and now we have the problem we saw before where we're missing the code for our dishes and our restaurants. So we need to compile not just main.cpp, but also restaurant.cpp and dish.cpp. And here we can see restaurants being defined more than once. So same kind of thing here. And I can fix this easily enough, which is a simple pragma once. Ooh, seems like there's more than one problem. Oh, I think this may have to do with my CPP file. Let's see here. Oh, yes, that's right. So here I've defined the, here I've written the code for the constructor, and here I've also written the code for the constructor. And one of them says to set up the available dishes, and one of them does not. So this actually should not be a set of braces. It should be a semicolon to say that there is a constructor, but it should be defined in the restaurant file, the CPP file. Okay, there we go. The problem is gone. And now we got cooking and salting and serving tacos. Let's check our main code. Did I do this right? So we cooked our things. We added our food. We did display, and it looks like it's only talking about our tacos. So that suggests to me that we may need to do some editing. I think it's the case that when I add these dishes, they may not be being added correctly. Oh, that's what it is. I got my spaghetti bolognese. I didn't put the spaghetti or the bolognese in it. So D2 should add food F2 and F3. And then we should see our spaghetti bolognese show up. Let's try that. There's my spaghetti bolognese. Got to make sure you actually put the food on the dish. Served an empty plate of spaghetti bolognese. Okay, that wraps up this exercise, I do believe, unless I missed something. Nope, all seems good to me. And let's move on to the last one. So last exercise is to make some classes and functions in their own files that represent different parts of a kitchen, such as oven, cutting board, mixer, and include these in your main program to use everything and compile it. For the sake of this, I may just, I think, do the oven. Just because it is a pretty simple one. But I encourage you to explore how some of these other things may interact with one another. So let's just make an oven. I'm going to once again close everything this time. Copy all this stuff over. Exercise 4. And let's make a copy as well as our oven.h. And our oven.h is going to, so probably if we have an oven, it needs to know what a dish is, which then will tell us what a food item is. So here's my oven class. My oven class probably needs to have a, let's say a max temperature, for example. And let's say, what else does an oven do for us? It cooks stuff. We can put something inside of it, I suppose. So let's say that it has contents. So let's say dish pointer to its contents. And let's just give a method called cook. Now, we have to be very careful here because we already have a utility function called cook. So maybe instead of cook, let's do something like bake. That's probably more appropriate. And what our bake function will do is it will actually set the dish's temperature to be the max temperature, just to keep it simple. Now, that means that our dish probably needs to have a temperature variable to track it. So over here, let's set that as our temperature. And then since our oven needs to be able to access the dish's temperature, I probably want to get a getter function for that and a setter function. So we'll say, and we also could, I suppose, make oven a friend class of the dish. That's not the worst idea either. So friend class oven. Did I call it oven with a lowercase o? Should be uppercase o, I think. Okay, uppercase O, friend class oven, so that it can access the temperature. And then the bake function, so let's duplicate oven.cpp. And here we just need to, oops, sorry, bake should have parameters, and it should take a dish, or no, it shouldn't take any parameters, but it should have parentheses. And now here, I'm going to define the bake function from the oven class. And it's going to go to this, what did I call it? Contents. That's going to give us a dish. And then from that dish, you want to set the temperature to be our max temperature. Sure. And our display function for our dish should also say this dish is temperature degrees. Okay, so if we did this correctly, we now have an oven. The oven can put a dish inside of it. It can bake that thing and set its temperature to the maximum temperature. So hopefully I did this right. Now our main function is going to need to include the oven. Let's get rid of this display for now. Let's heat up our spaghetti bolognese. So I'm going to make an oven O. Dot contents is the address of my spaghetti bolognese. So now I actually have a pointer to this dish. I'm going to say O.bake and then D2.display. So let's see if this will get a pointer to our spaghetti bolognese, bake it, and display it. I suppose to have a default value, let's say our initial temperature is going to be 0. And our oven max temperature is going to be, and this is a public variable? Yeah. Let's say we set it to 80. Let's see what happens. Compile, and I need to compile. Now, we're getting to the point where I'm compiling so many CPP files. One shortcut you can use is actually just star.cpp. This will compile every C++ file. Time-wise, it's the slowest, but typing-wise, it's the shortest. I got a pragma once in my main file. I think it's because this shouldn't be in fooditem.cpp. But I think it's okay. Oven has not been declared in oven.cpp, and that's because I forgot to include oven.h. Try this again. I request my temperature in the oven.cpp, but I think I mean to have an arrow here. So in my oven.cpp, the contents of the oven is a pointer, which means I need to use the arrow to get a temperature of that dish. Warning me a bit about including in the main. Multiple redefinitions of cook, salt, and serve. So I think this is, and so now we're seeing sort of the risk of doing the star.cpp. And the reason is, you'll notice that util.cpp here is also a CPP file that we've included directly in our main function, which means that we don't actually want to add that to the list of stuff we're compiling, because if we do, then we're going to be attempting to compile this file and fooditem.cpp after they've already been included in our main. So you can see it's getting a little bit messy. In next class, we'll talk more about how to simplify this process of compiling. But suffice to say, for now, we want to compile main, dish, oven, and restaurant. Our main needs to include oven.h, which it does, so that's great. We now compiled everything, and when we run it, our dish goes up to 80 degrees as we like. We got our cooked spaghetti bolognese. Hooray. So that wraps it up for this video. Next class, we will figure out ways that we can better organize this sort of messy file directory that I put together here. But at the very least now, the nice thing is that all the code that we've written here is spread out into different files, different modules, each of which is responsible for only one thing. Our dish class just tells you what a dish is. Our oven class just bakes stuff. That doesn't do anything else. Our restaurant is pretty much just responsible for containing dishes that we can put into it. And we don't have all this stuff chunked together into a single file, as you might otherwise. So that wraps it up for today. I encourage you to experiment with this. In particular, complete more of the classes and functions that you can do. Try cutting board, try mixer, and so on. And just see how you can integrate them into this program, sort of the way that I integrated the oven. That's it. Otherwise, I will see you in the next video.